Physics 10th grade, Class 78 Solutions, Minerva Bilingual School, Gracias, Lempira, Honduras, Central America. Let's go. Number 1. A block of gold and a block of wood have both have the same volume. If they are both submerged in water, which has the higher buoyant force? Well, buoyancy depends on the mass of the fluid displaced times gravity. The fluid in both of these situations is the same. Therefore, they will have the same buoyant force. And there you go. Their buoyant force will be the same. Their buoyant force is the same. Well, that was easy. Number 2. A 100 centimeter cubed block of lead weighs 11 newtons. That weighs 11 newtons is carefully submerged in water. Now, 1 centimeter cubed of water weighs 0.0098 newtons. First question. Once the motorcycle goes away. Thank you for leaving, motorcycle. What volume of water does the lead displace? Well, we know the volume of the fluid displaced is the same as the volume of the object if it is fully submerged. Okay? Therefore, 100 centimeters cubed of water is displaced. And there it is, 100 centimeters cubed. Next question. How much does that volume of water weigh? Well, we know that 1 centimeter cubed of water weighs this much. So the question is, how much does 100 centimeters cubed of water weigh? Well, 1 centimeter cubed is 1/100th of this volume, 100 centimeters cubed. So we just need to multiply this weight, this force due to gravity, by 100. In other words, basically just take this decimal right here and move it 2 places. So your answer is going to be 0.98. And for B, there's the answer, 0.98 newtons. I hope none of you have epilepsy because this moving of the screen might trigger you to have a seizure. I think that's the right word.
I can't reach the internet right now.
I'll connect real quick so we can ask Google about epilepsy in a second. C, what is the buoyant force on the lead? Well, we know that the buoyant force is equivalent to the mass of the fluid displaced times gravity. In other words, that's the weight of the fluid displaced. Mass times gravity is weight. So the weight of the fluid displaced is the same as the answer to B. So you'll see that the answer to C is the same as the answer to B, 0.98 newtons. The difference is that in B, this 0.98 newtons is down, right? And then the buoyant force is in the opposite direction, up. But the forces are both 0.98 newtons. All right, let's see if Google's ready. Define epilepsy.
Here's the definition of epilepsy. A neurological disorder marked by sudden recurrent episodes of sensory disturbance, loss of consciousness, or convulsions associated with abnormal electrical activity in the brain.
Yeah, there you go. Welcome to psychology class. Now back to physics. We're on D. Will the lead block sink or float in the water? Well, we just need to ask one question. What is more dense, the lead block or the water? We know that this 100 centimeters cubed, this volume of lead weighs 11 newtons. But that same volume of water, we know from the answer to B, only weighs 0.98 newtons. So obviously the lead is much more dense, more than 11 times more dense than water. Therefore, the lead block would sink. All right, number 3. The same 100 centimeter cubed lead block is carefully submerged in a container of mercury. Mercury is toxic. It's dangerous for people, especially if it's vaporized. It can cause you lots of problems. 1 centimeter cubed of mercury weighs 0.13 newtons. So before I even answer A, in my mind, I'm thinking, okay, we have 1 centimeter cubed and 100 centimeter cubed. Let's find out how much is 100 centimeters cubed. What's the mass? Sorry, what's the weight is what we want to find. What I'm thinking right now is let's convert this weight not convert it, but let's find out how much 1 centimeter cubed of mercury weighs compared to 100 centimeters cubed. So if we want to know 100 centimeters cubed of mercury, we're just going to multiply the weight of 1 centimeter cubed by 100. I hope that made sense. If not, rewind and play it slower on YouTube. So this number, like we did earlier, 0.13 times 100 will give us the weight of 100 centimeters cubed of mercury. So that's 13 newtons would be the weight of 100 centimeters cubed of mercury. So the first question, what volume of mercury is displaced? Well, in the same way, if we completely submerge the lead block, I'm telling you right now, the lead would actually float. But if you use a tool to completely submerge it so that it's underwater, it's going to displace the same amount of fluid as the volume of the lead block. So the answer to A is 100 centimeters cubed. Okay, let me see. You guys can see some answers here, like we talked about, 0.98 newtons, sink. The next one you can see the answer is 100 centimeters cubed is the volume of mercury displaced. If you guys do not know, mercury is a metal that is liquid at standard temperature and pressure. Okay. Next, how much does that volume of mercury weigh? Well, I just talked about that before we read 3A. This volume of mercury is referring to 100 centimeters cubed. We know that 1 centimeter cubed of mercury weighs 0.13 newtons. So 0.13 times 100 is the weight of 100 centimeters cubed of mercury. So 3B is 13 newtons. 3B, 13 newtons. All right, C. The reason I'm going back and forth between these two is it's easier to explain and less distracting if you cannot see the answers. Because if you see the answers, then it's easier just to look at the answer and not listen to my words. So anyway, whatever. It is what it is. C, what is the buoyant force on the lead? Well, this is assuming that the lead is completely submerged and that there's something holding it down and that none of the lead is above the surface. If none of the lead is above the surface, then the buoyant force is going to be the same as the weight of the fluid displaced. Okay. Now, the fluid displaced, once again, is mercury, and we just found out that the weight of that mercury is 13 newtons. So the buoyant force is also 13 newtons, but in the opposite direction. So there you go, 13 newtons. Upward, and then B is downward, toward the direction of the center of the earth, would be the direction of B. All right, now let's look at D. Guys, we're making fast progress on this. D, will the lead block sink or float in the mercury? Well, you can see that lead has a density. This is using non-SI units. They're not using the SI units here, but these units are still valid. They're just not the standard. They're using grams per centimeter cubed. Now, this we can see that the density of lead is 11.3 grams per centimeter cubed, and mercury is 13.6 grams per centimeter cubed. So which one's more dense? Obviously, the mercury is more dense. Therefore, the lead, which is a solid metal at standard temperature and pressure, the lead would float. I'm going to show you guys a super cool video. Now, like when you watch like videos of mercury and how mercury interacts with other objects, it's very counterintuitive because you think that metal would sink in a liquid, but watch this, it's crazy.
Here's my 110-pound iron-working anvil. I think we got this for making horseshoes and stuff.
And just so you guys know, this container is full of mercury. So he's playing with fire per se, figuratively, because all that mercury for him to deal with all that mercury is like kind of dangerous.
Back when we had horses. So let's set it in here and see if it floats. Okay, it doesn't.
I want to say one more thing. Guys, this anvil is like super heavy. Anvils are typically made of iron or steel or a mix of both of which are super heavy in that large of a volume of an anvil.
So you don't want to stay upright. Now let's let it tip over.
Look at that.
It is. It's floating. Look at that.
It floats as if it's like foam on Mercury. Why does it float? You know by now it's because Mercury is so dense. It's crazy. So dense. Not as dense as a neutron star. Not even close, but super dense. I also want to show you guys really fast a interesting conversion. Now you guys can see that on the worksheet they're using grams per centimeter cubed. So to convert to the SI units, kilograms per meters cubed, what you really do is you multiply by 1,000 to convert this entire unit at one time into kilograms per meters cubed. So this many, yeah, you see it, whatever. There it is. All right. Super crazy. That anvil was not made of lead, but a similar thing would happen. It's crazy, you guys. If you look up a video on YouTube if you want of like someone putting a coin on in a container of mercury, and it floats as if it's made of air because the mercury is so dense compared to the metal of the coin. It's crazy. All right, number 4. According to problems 2 and 3, does an object's density have anything to do? In other words, when they say have anything to do, they're saying, is it related to? Have anything to do is related to. Does an object's density have anything to do with whether or not it will float in a particular liquid? Well, yes. They're asking if it has anything to do. The answer is it has everything to do. It's completely related to whether it floats or sinks in a liquid. Now, as you guys know, the more dense the object, it will sink. If the object is more dense than the fluid, then the object will sink. If the fluid is more dense than the object will float, like the example in the video I just showed you. So D, lead is less dense, so it'll float. And here it says if an object is denser than the fluid it is placed in, it will sink. If the object is less dense than the fluid, it will float. Boom. Let's see how long this video is going for. Only 12 minutes. We're doing good. Making fast progress. Efficiency is the name of the game. All right, number 5. Based on the table of densities, explain whether the object would float or sink in the following situations. Let me just say, this problem is kind of a joke. It's not actually a joke, but it's so easy it's like a joke. So solid paraffin wax right here has a density of 0.87 grams per centimeter cubed in molasses. Molasses has, almost double the density of paraffin wax. Therefore, the wax would float, okay? Float. B, a bar of gold and mercury. Density of gold, 19.3 grams per centimeter cubed. Mercury, not as dense as gold, 13.6 grams per centimeter cubed. So gold is super dense. Super dense. Therefore, the gold would sink, okay? Now, interesting. Look at this. Just to clarify, if you were in this situation, but instead of an anvil, you had something like, look at this mercury. If you had a big block of gold, the gold would still sink in the mercury because it's so dense. Letter C, a piece of platinum in gasoline. You guys, platinum is even more dense than gold. We're getting crazy here. And then gasoline is not that dense, really not. So obviously the platinum would sink like a rock. It would sink like a rock in the gasoline. So sink. A block of paraffin. So here's the paraffin wax, 0.87 in gasoline. Density of paraffin, 0.87. Gasoline, 0.7. Which one's more dense? The wax. Therefore, the wax would sink. Okay? Let's look at the answers to confirm. Floats. Like we said, floats. B, gold and mercury would sink. Platinum and gasoline obviously sink like a rock. And paraffin and gasoline, and it would sink because the paraffin is more dense. And with that, we are finished with the answers. I will see you guys. Right now it's Thursday when you're watching this. So I'll see you guys on Friday, March 20th, tomorrow, at 10 o'clock a.m. for our next physics class. Peace out.